In this lesson, we are now focusing on all of our different types of angles and application of those angles. So like here, going back to reviewing with our triangle sum theorem here, but in now that form of that two-column proof. So what's given is we have our triangle ABC, and AC is parallel to BD, right? So remember with our proofs, we always start with our given and end with what we are trying to prove here. So here, for example, we're given that the reasoning is we have angles of a straight angle. Well, what angles do we have here that, according to here, that are forming that straight angle? Angles 4, 2, and 5, right? So angles 4, 2, and 5. So here, angles 4 plus angle 2 plus angle 5, right? Creating that straight angle, which is how many degrees? 180. And we know this because of the angles of a straight angle add up to 180. So now here, it states angle 1 is equal to the measure of angle 4. Well, how do we know this? Well, what is their relationship, right? Because if you recall, AC is parallel to BD, alternate interior angles. So the definition of alternate interior angles. So then that means, let's keep going with this. So if angle 1 and angle 4, what else could we state next? Angles 3 and 5. So the measure of angle 3 is also equal to the measure of angle 5, right? Why? Because of alternate interior angles. So now notice, this statement, number 2, has been really truly rewritten to number 5, except what happened? 4 became 1, and 3 or 5 became 3. So how were we able to do that? Well, notice that they are equal to each other. So here, ultimately, what did we do? We substituted these equal angles in the place of what we had here before. So that's how we can show that the angles 1, 2, and 3, which are all inside of the triangle, add up to 180 from here. So this is using substitution. So now getting a little bit more into other angles here now as well. Now, we focus so much on straight lines, but notice how here we definitely don't have a straight line. So if we're looking for X, we have a full circle here that we're working with, which is how many degrees? 360 degrees. So how are we going to solve for X here? Well, we do technically know all angles because of this 90-degree angle here. So combining like terms, 12x plus 3x, which is 15x, plus here we've got 60 plus 90, which is 150. Adding all of these angles up are equal to our full circle, which is 360. And now we're just solving our two steps, subtracting 150 from both sides. You get 15x is equal to 210. So now when you divide 210 by 15 here, you should get x is equal to 14. So now here we're solving for C and D. Now here, keep in mind, we can't really say that this is a bisector. We can't say, oh, that looks like 30, that looks like 60. Because, you know, right, see how this 90-degree angle is being split? We need to calculate. Now, notice with the two triangles inside of our right triangle. Right now, we've got a linear pair here. So let's go ahead and figure out, right? So if this is 180 degrees, that means that this other angle here, the linear pair adjacent, is 85 degrees. So now by doing that, can we figure out another angle? Yes, because we've got these two angles here inside of this triangle. So now we can find the measurement of D, because here we are given right now 149 degrees, right? Inside of our triangle, we have 85 plus 64. So right now we're at 149. So now 180 minus that 149 degrees. So that's why here D is equal to 31 degrees. So D is 31. So now let's keep going. Because if this is 31, now let's move over to our other triangle. Can we figure out this angle? Yes, because they're complementary. So if this angle is 31 and they have to add up to, right, 90 degrees, then this angle here, the adjacent angle, is going to be 59 degrees. Now, can we solve for C? Yes, because right now we have two angles inside of our triangle. So 59 plus 95, right? So right now we're at 154 degrees. So 180 minus that 154 degrees, leaving us with C is equal to 26 degrees. Then notice here for that reminder, we're looking for the measure of angle A. See how these two sides have arrows? That means that they are parallel to each other. So these lines are parallel, so keep that in mind. If you need to rotate, then rotate to C. Then they do share a common transversal right here. So if I were to look at this here and looking at my angles, I notice here that they are in the same spot, same position. So that means here A is equal to 39 degrees. So now go ahead and try this first one, drawing a picture, and let's see what your thoughts are if the answer is reasonable and explain how you know. So vertical angles here, so we've got vertical angles. So like let's say one angle is 2y, then the other angle is y plus 130. So how would we solve for y? Well, we would just set them equal to each other. 2y is equal to y plus 130. Then we gather our variables. So subtract y. Now I've got y is equal to 130. Now it's asking though about the angle measures. So like here, for example, if I were to plug this in, you get angle measure of 260 degrees. So is this reasonable? No, because here in the end, your angle measure needs to be less than 180 when you're working with vertical angles here. So if this was a full circle situation, fine. But with the vertical, we're talking about here, if you have vertical, then you're going to have that linear pair here. So this needs to be less than 180 degrees. The same thing here. Read through the problem and make a sketch in terms of this situation to see your thoughts on how you would set up and solve example 5, both parts. And so here you should have noticed that this problem here about the Louvre Art Museum is an isosceles triangle. The faces are isosceles. So what do we know about an isosceles triangle? The sides and the two bases are the same. Now here it says that at the top of one of the faces. So that means here this angle is 76.6 degrees. So it's asking for what are the measures of the base angles. So now notice first off, we need to figure out how many degrees are left between the two, right? So we need to subtract that 76 from 180 degrees. So here we've got 180 minus 76.6 degrees. So that means we are left inside of our triangle between the two base angles, 103.4 degrees. So if I've got 103.4 degrees, and we know that this is isosceles, so the two angles are the same, what do we then have to do? Divide by 2, right? They're congruent, they're equal to each other. So if we were to divide by 2, that means that each of the base angles are 51.7 degrees. Then how can we check? Well, if you add all three angles up, right, they should add up to 180 degrees. So the base angles were 51.7 degrees. Now, what's the measure of the angle between the ground and the edge of one of the triangular faces? So again, I'm going to redraw, but now we know we're at 76.6 degrees, 51.7, and 51.7 degrees. But it's asking for the angle between the ground and the edge of one of the triangular faces. So the ground, which is down here, right? And it's asking for the angle measure between that, the edge and the ground. So this is now just looking for, it was a way of asking for the linear pair, the adjacent angle. So that means, what did you have to do? Just subtract that 51.7, right, from 180 degrees. 180 minus 51.7 degrees, which gives you 128.3 degrees.